Hello class, in this lesson we're going to be looking at how we can model behavior that's sinusoidal using either a sine or cosine function. You know, there's so many things in life that are actually periodic and follow the form of a cosine or a sine function. You know, the way sound waves travel in the air, the way water rises and falls in the ocean, you know, the high and low tide, the motion of a pendulum or a spring, you know, a Ferris wheel going around in a circle, you know, circular motion. All of these can be modeled with a sine or cosine function. So today what we're going to do is we're going to look at, you know, a graph of some data, and we're going to figure out, well, what equation matches that waveform. Before we do that, we're going to talk about, you know, we've already talked about the idea of the period. We have not talked about frequency yet, though. So let's talk first about that. Now, remember, period is the length of time of one cycle. Length or time, and you know, now I'm going to throw some units here. You know, for example, seconds per cycle, that would be the period. Seconds per revolution, one revolution, that would be the period. When we talk about frequency, we're actually talking about the number of cycles within a specified unit of time. The units then are cycles per second, and you notice it's basically the reciprocal of the period. So, for example, the sound, you know, the note middle A has a frequency of 440 hertz. That's in cycles per second. Hertz means cycles per second. So what is its period? The period is the reciprocal, 1 over the frequency. So 1 over 440, and I'm going to put the units here, and then we, you know, punch it into a calculator. We get 2.27 milliseconds per cycle. That's the period. Time. This is the time of one cycle. So go ahead and do these on your own. 3, 2, 1. And here I used this, I used some scientific notation here first, then I turned it into nanoseconds. A nanosecond, 1 nanosecond is equal to 10 to the minus 9th seconds. Incredibly small amount of time. Your computer runs at 2 billion cycles a second, and one period is 1 nanosecond, or half of a nanosecond. Really, really short. Okay, now recall, we've looked at this before when we were graphing in the previous lessons. This is your basic transformation of your parent sine function. The A, this is our vertical up-down stretching, so it affects the amplitude. The B is our horizontal stretch/shrink, so if we're changing or stretching horizontally or shrinking horizontally, that's going to change the period. The period was, for a sine function, is 2 pi over b, because remember 1 over b is our scale factor, so that's, you see that here, 1 over b is the scale factor. We could solve for b by getting 2 pi divided by the period. Okay. H here is our horizontal shift. K is our midline shift, the vertical shift up and down. So, to figure out the period, basically to figure out the equation, we need to find out our value of A, K, H. To figure out the period, which leads us to the B value actually, we could look at min to min, max to max, we could look at min to min, or we could look at, you know, some other point on the graph where it's repeating. So, for example, here's some sinusoidal graph. We could look at, we can measure peak to peak, min to min, or just some other point, I could just draw a horizontal line and look for the repetition point, not just where it intersects again, but from point to the point of repetition, where now we've done one full cycle and now we're starting over again. So any one of these measurements would give us the period, which we can then use to find the value of B, the horizontal stretch factor. To find the vertical stretch factor, we look at our amplitude, and remember, amplitude is 1/2 of the swing, the total swing. So our amplitude here is from the midline to the top. So we could calculate this by figuring out max to min, the difference between the top and the bottom. How high is what's the maximum swing? And we divide that by 2. That gives us the amplitude, our A. The vertical shift, we can figure out how much, where is the midpoint, basically. So we find the midpoint between the maximum and the minimum. That gives us the midpoint line. And then to find the horizontal shift, this is the hardest one. First off, you have to choose between whether you're going to use sine or cosine as your modeling equation. And either is fine. One's not necessarily better than the other. Sometimes choosing sine is easier. Sometimes choosing cosine is easier, all depending upon the graph that you're given. Now, if you're looking at the sine, if you're going to use the sine function, the horizontal shift factor is going to be this shift from this point right here, the intercept of the midline, and the x is equal to 0. Because, if you remember the sine function itself, if there's no horizontal shifting, it's going to start right. Oh, actually, right. Let me fix this a little bit. It's going to start right here, actually. I need to actually fix this. Now, when the graph shifts over, I need to fix this here. The horizontal shift factor is this value right here. We've shifted it all the way over here. This is where it actually starts rising like that. So this is the correct H value all the way across here. Now when we look at cosine, we're going to look at where the maximum starts, how much that moved from the x equals 0 point. So again, here's our cosine. Let me move it back. Now in this case right here, this is where your cosine normally starts at the x is equal to 0. It's normally at its maximum, then it goes down and back up. But when it's shifted over, this is our h value. We look at where the maximum is and the distance to the x-axis. Okay, let's look at an example. Amplitude. So the amplitude, the total swing is 6. We divide that by 2. Our amplitude is 3. The midline is right in the middle between 1 and -5, so it's at -2. We use the average. 1 plus -5 divided by 2, we get -2 here. That's our midline. This is how much it shifted down. Our period, let's see. To figure out period, let's look at the minimum to the minimum here, since that's kind of convenient. The length is 2 pi. So B is 2 pi divided by period. I'll write that out again. Remember, it's 2 pi divided by the period. The period in this case happens to be 2 pi, so B is equal to 1 in this case. Choose sine or cosine. In this case, I just decided to use sine. No special reason in this case. And now the value of h, this is where it starts rising from the midline. This distance here is 3/4 pi. So that's the value of my horizontal shift from the starting point. Then I just kind of put that all together. So I have my amplitude here, 3. My B value is 1, so I didn't bother putting that in. X minus my horizontal shift factor minus 2, which is my midline shift vertically down. Okay. So here's an example for you to do. I'll show you the answer in 3, 2, 1. Now, just a comment here. The most convenient thing here was to use a cosine because it started at the max at the x equals 0 axis. And so I could have used sine, but then I would have had a non-zero shift factor. This is one of those examples where it's just easier to use cosine because then one of these values is 0. Okay, I'll show you the answers to these as well in 3, 2, 1. And let me explain this one a little bit more. Always, when you're doing a word problem like this, actually the starting point is to start by making a diagram here. So it says here, we're swinging a jump rope. The highest point is 68 inches. So let's actually label that 68. The lowest point is 4 inches from the ground. I'll label that here 4. The rope makes 1.5 revolutions per second, so I wrote that one over here. Well, I didn't write it. I figured out the period. I'll get back to that in a second. Write a model for the height of the function as a function of t. Given that the rope is, okay, here's an important thing, really right here. The initial value, the rope is at the lowest point when t is 0, so that's why I started right here. At t is equal to 0, the height is 4, then it goes up and down, up and down, up and down. Okay, here now we can calculate the amplitude, 68 minus 4 divided by 2. The midline is the average of the two, which is at 36. So if I were to draw that into our picture, I have 36 being our midline over here. Period, I need to, I'm given frequency. I have 1.5 revolutions per second. This is a frequency. I need to turn it into a period, so I take the reciprocal. So now I have 2/3 seconds per revolution. And now to find the value of b, it's 2 pi divided by the period. So I get 3 pi for my value of b. So now I need to choose the sine or cosine function. And when I look at this graph, it kind of looks like a cosine, except instead of starting at the maximum, it's starting at the minimum. So I'm going to deal with this using a negative cosine. So in that case, I have no horizontal shifting I need to do. So I'm ready to just write my equation. Negative 32, that's our amplitude. The negative because I'm starting at the min instead of the max of my cosine. It's basically a reflected cosine. B is 3 pi, so I put that here. No horizontal shifting going on. Plus 36, which is our value of k. Okay, let's do the Ferris wheel problem. Show the answer to that one. Same idea. I won't necessarily talk through all of this, but again, start off with the picture. The center of the wheel is 30 feet off the ground. The radius of the wheel is 25 feet, meaning it goes up from 30 up to 55. It goes down all the way to 5. 30 minus 5, or 25 is 5. We start at the 3 o'clock position, which is right here. That's going to be the midline point. We're going to start 30 feet above the ground. It's going to start turning clockwise, which means we're going to go down and then back up. So starting from here, I go down and then up. And this is important because this allows you to figure out maybe which function to use, as well as, what your h value should be. So anyways, I figure out my value of a, k. My period, I turned revolutions per minute into seconds here because it was requesting to be in seconds. And this is the key thing here. I chose the negative sign to model this because it starts at the midline. Instead of going up like the normal sine function, it's a reflected sign, so it's the negative sign. So that's what you see right here. Okay? That's the lesson for today. Have a good day, everybody.